Hello, good evening. It is now July 2nd, 2024. This video will be kind of like part 4 of the previous 3 about step-down transformers saving current. And it'll also continue from the videos before that about which include the AC voltage dividers. Now, this transformer puts out 15 volts AC from 120 volts AC from the wall, and it should put out 12.6, I think, volts. Now let's talk about that first. If it's rated at 1 amp, so that means the most that can come out of it is 1 amp. And according to my calculations I made here today, using that circuit, I calculated if 1 amp comes out, you only need 0.153 amps going into the primary coil. Now, I've did previous experiments, all these calculations I made here, and if I just hook up one of these bulbs to the output of the secondary, it measures 0.06 amps going into the transformer from the wall and 0.22 amps coming out. So 6 goes into 22 almost 4 times. So that'd be about, I calculate about 70% savings. When it should be 90% ideally, if these little wires on here weren't so thin, because they cause some copper losses where electrons escape and draws more current from the wall to provide the current needed for the load device. Now this circuit, I managed to run 2 light bulbs instead of 1, which is even better. Now, what happens here is the 2 bigger capacitors there, they charge up, and when they discharge and charge, they send extra current back to the green wires through the secondary, and actually the current's not used for anything. So what I did was I put this red bulb in parallel with it, and then some of the current goes into it, and it's doing something useful. And that little tiny capacitor there is only 10 microfarads, and it drops 13.36 volts over it and supplies that voltage to the black bulb with enough current to make it bright enough. And the bigger capacitors, I think they measure about 4 volts instead of 2 volts, which it should be. Now I'll just go through my calculations here. C2 is 10 microfarads, 13.6 volts. The current going into the transformer is 0.065 amps, and 0.485 amps coming out, which is the same current going into the AC voltage divider, and has 0.21 amps coming out going into the black light bulb. And that's about a 67% savings. And the same thing over here with the red light bulb, about 2.15 amps going through red, which is a little more than 67%. Now you add these two together, 0.21 and 0.215, that equals 0.425. And you subtract that from 0.485, which is what is coming out of the transformer, and you have 0.06 amps left that is kind of wasted because it's just circulating around into the secondary coil. Now here we got 0.65 amps going in and 0.425 amps coming out. That's powering the two little light bulbs. So that's a 6/7 savings. So 6 divided by 7 equals 0.86 or 86%. So that's how much this circuit is saving, 86% on electricity. Now what I'm going to do next is I bought these today. These capacitors are a larger value than the ones in there now, more capacitance. That means they should drop less voltage over them, but they'll provide more current. Now a 10 microfarad drops 13.36 volts over it. And that's because capacitors have inductive reactance. No, not inductive, I mean capacitive reactance. And the lower the value of the capacitance, the greater the total impedance, so more voltage drops over them. But there's less current available to charge them up. So I'll be putting the bigger ones in, and I'll see if they help save any current. And at the same time, I got these smaller ones here, smaller than 10 microfarads. One's 4.7 microfarads, and the other one's 0.47 microfarads. So that should really